As a director of National Green Corps, what I found was that students who are involved in science activities or environmental protection activities or environment conservation activities, they are into various levels of involvement. The involvement of student is very high when the student gets into doing science or doing environmental work rather than seeing and documenting. But science has this important aspect that when you do something, before that you read about it and you prepare yourself so well that you are conceptually clear, you have a scientific principle in your mind, and then when you observe whether that principle is in operation or not, we will be able to find out. So science has three aspects. One is doing, second one is documenting, third is seeing. But in terms of our exposure in the classrooms or in your day-to-day life, most of the students get exposure to reading science. Reading science is different from seeing science or documenting science. Reading is the first step of science learning. So Science Congress is about starting with reading, going beyond reading into seeing science and documenting science, and finally doing experiments with science. That is what makes Science Congress a brilliant method of exploring science or instigating students into doing science and being scientists. So doing leads to finally being. So for a person to be a scientist, one has to go through the experience of science. So experiencing science, for instance, on energy, as an environmental conservation group, we are always, from National Green Corps, we are always keen on how, not just learning about how energy is produced or how energy is transferred or transformed from one form to the other, but we are more interested in how energy is conserved. So for that to happen, the student needs to understand, of course, the basics of how energy is produced. So he reads through that, and then he sees how energy is consumed, and then he does energy conservation. Energy conservation gets into his practice, and after he finds that energy is conserved, then he documents how energy is conserved. Sometime back we did this activity with students along with the energy conservation mission. What we found was that when we want to manage something, we have to first go to the level of monitoring. If we have to go to the level of monitoring, the step prior to the monitoring is measuring. So measuring can lead to monitoring, monitoring can lead to managing, and managing can lead to conservation. So this is how these steps are. So science activity, doing science activity is different from being a participant in National Children's Science Congress or any science congress for that matter. In Science Congress, you have an opportunity to present what you have done. So the steps are important here. The first step, how you started your basic work, and then how did you get that idea, and how you have grouped in people's support for that, your classmates' support for that, your teachers' support for that, your family support for that, and how you are thrilled by this idea and how you are excited. Science comes out of excitement, enthusiasm, the quest inside us to do something and to show up something is very, very critical in science activity. That enthusiasm comes out of the involvement. If science gives knowledge, then knowledge has a purpose also. So science needs to be purposeful. That is what group of there are two streams of thought in relation to science: knowledge of science and knowledge generated by science and the way science is conducted. One group would say that science is for itself. Science should grow as per the scientific canons. The other group would say that science is for society, science is for people, science is for all of us. Science should help us to deal with our day-to-day issues, problems, our and help us to lead our future better. So in that context, when we are looking at doing science, then we look at science being supportive of sustainable development, supportive of our being able to face one challenge, or if you want to say, you can say problem also. So in a particular instance, for instance, we have now energy crisis. We have a lot of problems related to energy. The production is not enough. There is a lot of transmission loss. The amount of energy that is produced and finally which reaches the consumers, there's a huge gap in that. And the purpose for which the energy is produced and the way it is utilized, there's a huge difference. And the way we generate power, sometimes it is lopsided. We are not focusing on the source of energy, source of generation of energy, which is regular, renewable. So these are the things which come up when we are doing science relating to energy. So in energy conservation, when as a conservationist or as an environmentalist or as a person who is interested in doing something about energy, the smallest thing that the student can do is do a switch off campaign and practice switch off. So first is he has to find out how much each light, each fan is consuming in a particular hour or in a particular day, and how much each appliance consumes. And so it is about how much. First, what? Locating fan, tube light, air conditioner or various energy consuming gadgets. Next is monitoring them, how they are used and how much is it used. So for doing that, you need to do measuring. So how much each bulb consumes, how much a CFL lamp consumes, how much a LED lamp consumes, how much a fan consumes, and what speed of fan do you consume more energy. So these things first we identify, get into measurement of usage of something, usage of energy, and then we get into monitoring. Okay, so we reduce this, we increase this, we reduce this and we increase this. So what is that happening? So the student gets into actually measuring, then monitoring the way energy is consumed. Then goes into the level of managing and conservation. Managing in such a way that, see, load shedding, we suddenly say that there is a power off, switch off, or power cut, or load shedding. So when you say there is a power cut, it is basically load shedding. It cannot take more. The transformer, the substation cannot take more load. That is, there is higher demand than the supply. So the demand in a particular direction is curtailed so that the supply can be equal to the demand. So you have higher level of demand, so you cut down some level of demand in particular direction and then release it to another direction, so that the energy consumed, energy conserved and energy produced, they are all on the similar plane. So why is load shedding done? Why is a particular time the load shedding is done? Why is there? It depends upon the demand. So when do you have highest level of demand? When do you have highest level of conservation? When do you have highest level of production? When you have high production and then less demand, what is happening? So this is all in terms of our consumption patterns, our production patterns, our distribution patterns. This measurement is done and this is documented. Most important aspect of science activity is documentation. How did I come to arrive at whatever I have arrived at? How do I say this? I said this. So if I am saying that a tube light consumes half of the fan's consumption. So how did I come to know? Did I measure this? Did I measure that and then equate them? So that method, and from what time to what time did I measure? From 5 o'clock to 6 o'clock or 6 o'clock to 7 o'clock? And is this 1 hour and this 1 hour equal? So that type of nitty, these details we get into when we get into documentation. In documentation, we are writing the process of science. Process of science is equally important as much as the result of science. So science methodology is very important, and by the soundness of methodology, we come to a conclusion on the soundness of the results. So the rigorous methodology is what is intended in the Science Congress. So when Science Congress, when there's an evaluation, or when a student is getting ready, or a teacher is getting ready for Science Congress, then they have to look at how they are going, the steps. Step 1, step 2, step 3. Have they documented the steps? And have they gone in the way they have documented the steps? So generally, there are experiments, so there are trial and errors. Finally, when you are coming to some conclusion, you get through a process. So that process documentation is very critical. Process documentation can be photographic documentation, videographic documentation, or writing down sketch, and also step by step. And the timeline is very critical. When did you start what? Suppose you are saying that energy consumption is very less when compared to production. Then you have to say which month are you talking about? Which month is the consumption of farmer more than the industry? Which month is the industry consumption more than the farmer? Which month is the domestic consumer consuming more? So timeline, year, and at that time what is the temperature in the atmosphere? If the temperature is low, even if it is summer, if the temperature has suddenly gone down because of depression or whatever reason, so 30 degrees if the temperature is in the ambient atmosphere, then your consumption of energy in terms of electricity for fan or cooling or for refrigeration is much less. But if your temperature is 42, 43, 44 degrees, the same month, then you have to see, okay, then that is the time when your consumption is increased. So there are various indices, and the context is equally important as much as the content of science. Context is to be established. That is when you document so and so place, so and so time, when these conditions were there, this is what is the result. So if the conditions change, the results change. It is not that the same result will come when the conditions are, again, time and space are organs of perception. The time is important, the space is important. We have to do the science activity based on that and document every step of this activity. Documentation can be, first when you are doing the activity, you may not be able to document it in the way it is required for the Science Congress. But your rough notes is very, very important. After you do your rough notes, you write step by step what you have done, and in a presentable fashion. That is when a student or a teacher well prepared for Science Congress and student who has done science work but could not present comes up very clearly. So that is what whenever I discuss with students or teachers like you, it is my suggestion that your process documentation is important. The way you have started your work, in fact, how you conceived it, how did you get this idea, and who inspired this, what are the conditions under which this experiment was done, or this trial was done, or this topic was selected. So that is very, very important. And also the results, and also how you communicate these results. We get results, but did you communicate results, and whom did you communicate with, and what is their reaction? The perception of the scientific community and also the public around, those people who are not involved in the science activity or who are not involved in science activity, what is their perception with regard to your result is also important. So science is for influencing, science is for not only science activity, science is for influencing the society. When science is for people and science is for changing our thinking or making our life better, making human interaction with nature better, making conservation as the principle of sustainable livelihood, sustainable life, sustainability on the planet, then it is always required that we communicate with the community, communicate with the society, communicate with the people around us. That is important. So documentation of that communication process also forms part of the Science Congress activity.